Welcome to Gasket U. I'm Ryan Hunter, the gasket professor. Hey, how you doing? Today we're going to be working on a small block Chevrolet, and the project here is to change out the copper O-rings to stainless. The reason there is we prefer stainless O-rings to copper because we're using a copper head gasket, and we'd like to deform the copper head gasket rather than have the soft copper O-ring deform as well. Just gets a better seal if we use stainless steel. So let's get about taking these things out. You'll need one of these handy little hooks and go after the joint where the copper gasket or the copper O-ring begins and ends, and these things can get kind of tight in there, so get this little pick in there. Let's see if we can get it started coming out. There we go. Now we can just pull this copper O-ring out of the motor, and it's leaving behind a nice square O-ring groove that's already been cut into this block. The trick here with an O-ring is that, I don't know if you can see it in the camera, but you don't want to leave a gap. A gap, if you were just to take a set of wire cutters and clip this thing and leave it cut, it's got an angle to it, and that angle, when it's tapped in, can leave a groove. Well, that groove presents as a leak point for combustion. So get yourself a set of pliers and just file the end of that wire flat. Not that tough to do, it doesn't take a long time, but that gives us a good flat end of the wire to start with, and we're ready to start putting it in. Now, what I've got here is a tool that's available in the SCE kit. This is our O-ring wire kit, part number 31542. It includes an instruction sheet, enough stainless O-ring wire for 10 cylinders, and this little puck. The reason for the puck is so that you don't dent the wire with the ball peen hammer when you're putting it in. So you'll start out like this with the prepped end of the wire. Now, here's another important point. We want to begin and end the O-ring wire near a bolt. That'll give us better clamp load at the joint part of the wire, and therefore a better seal. So let's begin putting it in. So we've got our O-ring wire started next to a bolt, and again, this is important that we begin and end right on a bolt. And now we're going to take our tool and work our way around this wire, tapping it into the O-ring groove. And sometimes you have to get pretty stiff with it to get it to stick there. The O-ring groove is supposed to be cut so that it's got an interference fit. In this case, we're using a 41,000 stainless wire. The O-ring groove is cut 40 thousandths wide, so we've got that 1/1000th of an inch interference, which is holding it in place as I go around. So we're working our way around this wire, and at this point, what you'll want to do is do a test cut or a trial cut, and we'll leave it intentionally long because we're going to file this end of the wire as well, so that when we're finished with this installation, if I do my job right, you'll barely be able to see it in a close-up shot on that camera. So we'll cut this guy just a little bit long, and then I am going to file it. Okay, so our wire is cut now just a shade too long, and we'll take our pliers again and carefully put the end of the wire into the pliers and begin to file it down until we get it to fit properly. Being careful not to damage the wire that we put in. This is really not a complex operation, it just requires a little bit of attention. So we've got our wire now cut and filed to fit. and we're just going to put that guy in place. And there we have a pretty good O-ring installation. Let's seat that in. Now, this entire cylinder O-ring required maybe 10 minutes. So in the engine, the entire engine, you might have an hour, maybe 2 hours in this whole project. But once this job is done, your O-rings are going to be permanent. And now the only thing you have to worry about is putting the rest of the motor together. And what you've done here is sealed up the motor, the combustion seal, tightly. And it really is, in my opinion, less work than degreeing a camshaft. Equally as important, because we're talking about sealing the combustion pressure here. So the main points are: use 304 stainless wire. We want to have the block prepped so that the groove is cut to provide a 1/1000th or so interference fit. You could actually have up to 3. It's just tougher to get the wire in the hole. And then use, like I say, the 304 stainless wire, which is available from SCE in the kits. We also have it available in 1-pound spools if you'd like to do it in a bulk thing. But this project really doesn't require a heck of a lot of technology. Now, typically the cut that's done to the block is done either on a boring bar in a machine shop, or it can be done with another tool. A tool that Iskandarian sells is called a O Matic. And I think in one of the future video series issues we're going to actually take a virgin block and put a cut in it for the O-ring and start from scratch. Now that we've got the O-rings installed, at least in this case just one stainless O-ring, but we'll just go ahead and measure these since we've got the copper O-rings to measure from. We often get questions: how high should the O-ring be? What kind of wire height should we have out of the deck? And again, that really is a function of the gasket thickness. It's more critical on a thin gasket than it is on a thick, but the rule of thumb is that we don't want the O-ring protrusion, the wire height, any more than 1/4 of the gasket thickness, 25% of the gasket thickness. So let's go again with a 40/1000 gasket, because that's the most common thickness. It's what this little small block was set up to run from the factory. So we would be shooting for a wire height of around 10/1000. And a way to measure that, if you've got a dial caliper, one way is to just set this thing and use the tail piece of the dial caliper, set the tool between the two O-rings, and then just run your thumb piece down, and it'll give you roughly, what this guy's showing is about 12/1000. Now, if you don't have a dial caliper, there's an easy way to do it, and it's every bit as accurate. And all it requires is some kind of a straight edge, and what I've got here is just a simple stainless steel rigid rule and a set of feeler gauges. So what you would do is just stick your feeler gauge in there until the point, say start at 10/1000 or so. And what I'm measuring, I've been messing around with this for a minute, but what I'm getting between the cylinders here is right at 12/1000, like our dial indicator was showing us. So over here, we'll check it. So if you're on the phone with your gasket company and saying, hey, I've got a gasket height, a wire O-ring height of 12/1000 of an inch, what can I run? Well, if these wires were truly seated and we were going to end up with 12/1000 wire height out of the deck, I would recommend a 50/1000 thickness gasket. The 12/1000 wire height might be just a shade too high for a 40/1000 gasket, and what that would do is provide a really great combustion seal, but it actually unloads the rest of the gasket, and we might have coolant leaks around the rest of the gasket body. So again, the O-ring height is critical to the thickness of the gasket. A copper gasket will allow about 25% of its thickness in wire ring height and still allow good sealing on the rest of the gasket body. I'm Ryan Hunter, the Gasket Professor. This has been another episode of Gasket U. Email tech questions to us at tech@scegaskets.com.